Alright, in this video we're going to take another look at medians. Previously, we looked at how the median, of course, is a segment that travels from a vertex. It goes from the vertex of the triangle to the midpoint of the opposite side. And we use that to do some calculations about how long either one of the shorter segments or the entire length of the side is. And then we used it to solve for x. And next, we're going to use it to find the length of either an entire side of the triangle or a portion of the side, half the side. But here we're trying to find EP. We know that ER, that's right here, is 5x minus 3, and we know that EP is 4x. Now, EP, that's the entire side of the triangle, is 2 times ER, because ER is just from the midpoint to the edge. So now we'll substitute our expressions. EP is 4x, and ER is 2 times, and make sure you put your parentheses in here because it's 2 times the entire expression, 5x minus 3. Well, first thing we're going to do here to solve for x is we're going to use our distributive property. Nothing changes over here. 2 times 5x is 10x, and 2 times negative 3 is negative 6. Alright, next we want to get all of our terms that have variables to be on one side. So I don't want this 10x here, I'm going to take it away. Of course I have to do the same thing over here. Now, 4x minus 10x is a negative 6x, and we still have our negative 6 over here. Now, to isolate the x, I just want to divide by its coefficient, which is negative 6. Divide by negative 6 over here, and we get x equals, and negative 6 divided by negative 6 is 1. I don't want to stop here because we weren't asked to find x, we were asked to find EP. So in this case, we have to go back to our expression for EP, which was 4x. EP equals 4x. So we're just going to substitute for x the value that we calculated, which was 1. And so EP equals 4. It's a good idea to kind of put a box or a circle around your answer there. So the steps were, set up our equation, solve it, and then substitute that value back in for x. Let's do another one. Here we're supposed to find DF. That's again the entire length of this side. We know that BF is 3x plus 2, and that BD is 4x minus 1. Those are just the 2 halves of the side. Remember, B is the midpoint. So here, we're going to start out with BF equals BD. And we've got the BF is 3x plus 2, and BD is 4x minus 1. And now we need to solve for x. Well, first thing I want to do is I want to write an equation that has all of the variable terms on one side. So let's get rid of this 3x. Of course, we're going to get rid of 3x from over here as well. So let's see, that's going to leave us with a 2. 4x minus 3x is 1x. We won't write the 1 there, we'll just leave it off. Minus 1 over here. Now we want to isolate the x by getting rid of any other terms over here. So we're going to get rid of this negative 1 by adding 1. And that leaves us with 3 and x. So x is equal to 3. Now we weren't asked to find x, we were asked to find DF. So we're going to have to go back in here. A couple different ways we could do this, but DF is equal to BF plus BD. And BF is 3x plus 2, and BD is 4x minus 1. Now they put the parentheses there just for the visual. Not necessary. So now we're going to combine our like terms. I have a 3x and a 4x. That's a 7x. And then I have a positive 2 and a negative 1. So I'll combine those for just a positive 1. Okay. Now we'll go ahead and substitute our value here for x, which I suppose it could have done right from the beginning, but I would have had to substitute here and here. A little simplification works out. So that's 7 times 3 plus 1. And see, 7 times 3 is 21 plus 1, which is 22. So df equals 22. We could have done this another way. We could have calculated, say, bf by itself. Let's see, 3 times 3 is 9, plus 2 is 11. And since that's half, we would just double it, 11, and that would get to be the whole thing here. Or we could have done, I'll write this one out, 4x minus 1, that's bd, and 4 times 3 minus 1, 4 times 3 is 12 minus 1, 12 minus 1 is 11, so we could have doubled that. So several different ways to go about doing it. But either way, remember that you've got to figure out what's the relationship between the two expressions that you're given, the two sides that you have lengths for, or not two sides, but two segments. Are they the same length like it was here? Or is one of them twice as long as the other, like over here? Set up your equation accordingly, either equal to each other or one equal to twice as the other one. And then you want to solve your equation. Once you've solved your equation, you take your value and you substitute it back into the original expression. Or in this case, we had to kind of write our own expression to find out the length of the segment that you're looking for. Good luck.